Hi, I'm Arvind Bright and I'm from the gRPC team at Google. Today we'll be talking about gRPC and Kubernetes, a powerful combination to build microservices application. Today I would like to introduce you to a new Kubernetes Gateway API resource, the gRPC-Route. For folks who are familiar with gRPC, you should already know that gRPC is a modern, high performance, cloud native RPC framework. What that means is gRPC is general purpose, can be run on most platforms and OS. gRPC can run on a server, on your mobile device, in the browser, and also on embedded systems. gRPC is language agnostic. This is the core essence of gRPC. We support C, C++, Go, Java, Python, Node, to name a few. gRPC is open source software and is accepted to Cloud Native Computing Foundation since 2017. Now let's bring in Kubernetes. It's a leading platform for managing containerized applications like our microservices. Kubernetes help us deploy, scale, and manage these services with ease. With the widespread adoption of containers among organizations, Kubernetes, the container centric management software, has become the de facto standard to deploy and operate containerized applications. Together, gRPC and Kubernetes form a fantastic foundation for building robust and scalable microservice architectures. But as our system grow, we need more advanced ways to manage the traffic flowing between these services. As our microservice deployments become more complex, things can get a bit tricky. We need to ensure that requests are routed to the right services, that traffic is balanced effectively, and that we can easily roll out updates without disrupting our services. Traditional ingress solutions in Kubernetes often rely on basic path based routing. This can be limiting when we need more fine grained control over how traffic is handled. Imagine you want to route requests differently based on headers, or you want to gradually roll out a new version of a service to a small subset of users. This is where things can get challenging with basic ingress. Fortunately, the Kubernetes community has developed a powerful solution, the Gateway API. This API provides a more modern and flexible way to manage traffic into your cluster and within the Kubernetes cluster. Let's understand what the Gateway API is. It's fundamentally a collection of resources that models service networking in Kubernetes. Think of it as a more structured and comprehensive way to manage how traffic enters your cluster and gets routed to your services. Now, you might be wondering, how is this different from Ingress? Well, the Gateway API builds upon the lessons learned from Ingress and offers significantly more flexibility. And that flexibility comes from a few key design principles. One of the most important aspects is that it's role oriented. This means it provides resources that directly correspond to the different roles involved in managing Kubernetes networking. We will explore this in more detail later. This separation of concerns allow for better collaboration and clearer responsibilities. And because it's role oriented, role based access control can be used to control resource access, ensuring that only authorized users can make changes. Another crucial benefit is portability. The Gateway API is designed to be implemented by many different providers. This means the same manifests could be reused in different cloud providers. No more vendor lock in. Makes it much easier to migrate your application between environments. And finally, the Gateway API is incredibly expressive. Its core functionality allows for advanced configuration that simply wasn't possible with Ingress. We're talking about more granular control over traffic routing, header manipulation, and much more. This is where resources like gRPC-Route really shine, which we'll get into shortly. So, to summarize, the Gateway API is a powerful, flexible, and portable way to manage service networking in Kubernetes. It addresses the limitation of ingress and provides a more robust and scalable solution. In the next section, we'll dive deeper into the gRPC route resource and see how it leverages these benefits. In the original design of Kubernetes, ingress and service resources were based on a usage model in which the developers who create services and ingresses controlled all aspects of defining and exposing their application to the users. In practice, though, clusters and their infrastructure tend to be shared, which the original ingress model doesn't capture very well. A critical factor is that when infrastructure is shared, not everyone using the infrastructure has the same concerns. And to be successful, an infrastructure project needs to address the needs of all the users. Gateway API defines several distinct roles, each with an associated persona, as a tool for surfacing and discussing the differing needs of different users in order to balance usability, flexibility, and control. Design work within Gateway API is deliberately cast in terms of these personas. There are these roles and personas in the Gateway API, and here are the different Gateway API resources for which each role is responsible for managing. Let's look at each of them in detail. First up, we have the infrastructure provider. This is the team or organization that provides the underlying implementation of the Gateway API. They are responsible for the gateway class resource. The gateway class essentially defines a template for creating gateways. It specifies the capabilities and configuration of the gateway implementation. Think of it as a blueprint. It's an infrastructure provider that installs the gateway controller and creates the gateway class. If your infrastructure is deployed in the cloud provider usually provides you with the vendor specific gateway class. Next, we have the cluster operator. This role is typically handled by your platform or operations team. They are responsible for managing the gateway resource. The gateway resource represents an actual instance of a gateway in your cluster. It's the point of entry for traffic. The cluster operator uses the gateway class to create a gateway, configuring things like the listening port, IP addresses, and TLS settings. They are responsible for the lifecycle of the gateway. Finally, we have the application developer. This is where you, as a developer, come in. You're responsible for defining how your applications are exposed and how traffic is routed to them. This is done through the various route resources. The Gateway API provides several route resources, each tailored to a specific protocol. These include HTTP route for HTTP traffic, TCP route for routing raw TCP traffic, gRPC route, which we'll be focusing on today, for routing gRPC traffic, and TLS route for routing TLS traffic. These route resources allow you to define rules for matching and forwarding traffic based on things like host names, paths, headers, and more. The developer attaches these route objects to a gateway object. The Gateway API can handle traffic from outside your cluster to inside, which we refer to as North-South traffic. Essentially, this is all about routing external traffic into your Kubernetes cluster and exposing your service to the outside world. If you're familiar with Kubernetes Ingress, you can think of the Gateway API as a more powerful and flexible replacement for that functionality. With the Gateway API, you can achieve various north south traffic management tasks, including load balancing, TLS termination, path routing, basically everything that allows a client outside of the cluster to access services within the cluster. Now let's just shift our focus to traffic within the cluster, known as east-west traffic. Using the Gateway API for east-west traffic allows you to implement traffic splitting, gradually rolling out new versions of your services, perform header-based routing, directing traffic based on headers within the request, or enforce MTLS, securing service to service communication. Provide advanced service to service communication patterns that are essential for microservices. This is the core essence of the Gateway API. This enables you to build more robust, resilient, and secure microservices applications. So, we have covered how the Gateway API handles both external and internal traffic, providing a unified and powerful way to manage networking in Kubernetes. Now, let's focus on a specific resource that truly showcases this power for gRPC workloads, the gRPC route resource. In August 2022, the gRPC team introduced the gRPC-Route API. This dedicated API, stemming from a Gateway API enhancement proposal, addresses the specific need for routing gRPC traffic, which utilizes HTTP2 and protocol buffers under the hood. While HTTP route could technically handle gRPC, gRPC route significantly enhances the user experience by providing method matches. This allows for precise routing based on gRPC services and methods, as you can see in the proposal on the right. Notably, gRPC route has now reached V1 and is available in the standard channels since Gateway API version 1.1. It's great to see so many implementations already supporting gRPC route today. Conformance tests for gRPC route have recently been added, and we are happy to share that we have already passed on Contour, Cilium, and Envoy Gateway. With multiple implementation passing conformance test, we have met the last graduation criteria for gRPC route. With gRPC route graduated, we are hoping for more implementation, adding support for it so more users can get access to it. Beyond its functional advantages, gRPC route significantly enhances the user experience, particularly with its method matches. We understand that while using gRPC, gRPC relies on HTTP2 URIs. You should need to be concerned with those underlying implementation details. Method matches abstract that complexity, allowing you to route traffic based on gRPC services and methods directly. In common scenarios where you route an entire service, simply omit the method field. For more specialized cases like routing all RPCs with a method name across multiple services, you can omit the service name. We have more user experience improvements planned for gRPC. Okay, that brings us to the end. Please watch the other videos on our channel to know more about gRPC. Thank you.